No matter which type of plant you want to grow, they all have one thing in common. They are thirsty. Depending on the type and growth of the plant, you would water them individually and manually. But what if you're away, maybe on holidays, maybe you're super busy, or maybe your location of your plants is where it's sheltered from the rain, or maybe you have a drought period. To face all those issues, we will build an automated IoT watering system. But before we get into the technical details, let's take a look on my setup at home. So personally, I live in a city and I grow my stuff in containers. Those containers are placed on my balcony, so the amount of soil I have that could act as a reservoir is pretty limited. Therefore, my plants need especially frequent watering and always the right amount. Another complication is that I don't have only one container, I have actually several containers, all located on my balcony but not interconnected in any way. So one straightforward solution could be connecting all the containers via a main pipe to a tap and then have individual branches of this main pipe connecting to the individual containers. But there's one problem with this solution. My containers are not growing all the same type of plants, or maybe they are in different stages of growth, and actually the containers are also not all the same size. So the water needs are very different from container to container. So how to accompany those individual water needs of each container? One very simple and mechanical way would be adding manual valves to each individual outlet. This type of solution is very common in normal garden watering systems. You have a little nozzle at the top and then you can basically adjust the water flow by increasing or decreasing the diameter of the holes or the nozzles at the end of the pipes. Having the water distribution solved like this, we would just add a little timer to our tap and then water everything automatically. If we want to adjust the water distribution over time, we could do this manually or we could replace the manual valve with an electrical valve. But to be honest, that's not a solution that works for me because, as mentioned, I have a balcony and unfortunately I don't have a tap on my balcony. So I need to work with a reservoir placed on my balcony. I also think this is a more common setup, whether it's a balcony or an off-grid setup where you don't have a pressurized water pipe. Besides that, using tap water is obviously more expensive and less sustainable instead of collecting rainwater and then redistributing this rainwater once it's more dry. So my idea is having a reservoir, connecting individual pipes from the reservoir to individual pumps. Of course, you could argue why using individual pumps and not one pump and then having a main pipe running towards the containers and having then branches of this main pipe going to the containers and using all this with one pipe and maybe a couple of valves. Well, beside the reason I will touch on in a minute, basically I want redundancy. In case I have a pump failure, in this setup I'm only losing one container. With one main pump I would lose all my containers, and I really want to have a reliable and not really redundant but resilient system. So what I'm going to do is I will run from each individual pump and individual pipe to each container. Of course, this is increasing my costs on the spend on pumps, but also decreasing costs for potential valves with only having a pump to turn on and off, or even using a signal to increase or decrease the speed and therefore the flow rate of the pump. Talking about the automation part, I will opt for an ESP32 as a Node MCU breakout or developer board. This is due to the Wi-Fi connectivity that's given and also due to the price point. I want to have a very cheap and simple setup so everyone can basically repeat this on his own balcony or on its off-grid setup or wherever you are where you need a simple watering solution. To activate the pumps, I will use relays. So in case you're not familiar with a relay and how it works, check out our video about this. Then we will connect the relays directly to the pumps and therefore the relays will do the heavy lifting and the ESP has only a little current to provide to activate the relay. In the next step, I may want to put a Darlington circuit between the ESP and the relay because, as you know, the relay is also a coil and therefore pulling actually quite a significant current that could damage our GPIO pins at the ESP in the long run. Coming back to the other advantage I mentioned before of using individual pumps instead of valves at the end of the pipes is basically the distance, because the distance from my ESP to the container would be super long, so I would have to run, in my case, maybe 5 to 10 meters each time, so I would have a lot of cable to use. which is obviously also a little bit of a cost driver, but I'm more concerned about troubleshooting. So in case I'm encountering a malfunction, I would have to check each individual cable, I would have to check the valves at the end of the containers. Also the containers are filled with soil, so in event of rain, the valve would be exposed not just to rain, but also would get exposed to the soil that's like maybe bouncing back up to the valve and the raindrop hits the soil. So all those type of things. I like to have all my electronics and all my IoT devices and all my wiring centralized, and with a setup like this I have all really close to my reservoir. I can have all enclosed in one housing, very easy to troubleshoot, very easy to measure if something goes wrong. So this is my basic setup. Obviously I will add sensors and stuff like this in the next step, but I want to build this project stage by stage. So this is the first stage, the automation, the activator side of things. Next stage will be some sensors and also obviously an interface that I can interact with my system from my phone, no matter where I am on the world. So this is my concept. Actually, I ordered all the parts yesterday already, and I'm planning to assemble everything in the upcoming week. So stay tuned for the progress of the project and feel free to replicate everything I'm doing here. I will put a part list in the description of the video, so you can go along with this project as I do, or later on replicate it in case you have the same need as I have. Thanks for watching and see you next time.